It is 2 a.m. on a Thursday. The sprint deadline is looming, and your automated workflow is collapsing. Terminal errors are flooding the screen, latency is spiking, and tasks that executed perfectly yesterday are inexplicably failing. The immediate instinct is to blame the AI. We assume we've hit a hard token limit, or that the model has simply lost the thread and drifted out of context. But look closer at the workflow. We are throwing multi-step, multi-agent tasks at a single language model and hoping it figures out the sequence on its own. Brute forcing complex logic without a rigid structure practically guarantees a compounding chain of errors. We have been diagnosing the wrong problem. We aren't hitting the limits of artificial intelligence, we are hitting the limits of bad architecture. For the last few years, the default way to build AI software has been a pattern we can call the wrapper. You take a large language model and plug it directly into your application. This animated flowchart maps that approach. We see a single, linear path from the user to the prompt, to the model, and out to the final output. The fatal flaw here is the complete lack of a safety net. When the model drifts off course, the output simply fractures, passing the error straight to the user. Now watch what happens when we try to scale this. If your product requires 3 different models for 3 different tasks, the wrapper pattern forces you to manually hard-code connections. You are left hoping those fragile threads hold together. They inevitably snap under pressure. A wrapper is an entirely unmanaged process. If a single prompt in that chain fails, your entire product crumbles. The developers building reliable, enterprise-grade tools have abandoned this approach. They've stopped obsessing over prompt engineering, the act of talking to AI, and shifted entirely to context engineering. Having a massive 2 million token context window is functionally useless if the execution layer underneath it has simply no memory of the actions it took 5 seconds ago. The structural solution looks like this diagram. We place an orchestration layer hierarchically above the AI models. This acts as the system's brain, turning the models themselves into simple, distinct execution nodes beneath it. The models aren't breaking. The absence of orchestration is what causes the collapse. To see how this works in practice, let's tear down that broken sprint system and rebuild it from the ground up using a specific architecture called Zyvora. This framework rests on 4 load-bearing pillars. Tier 1, input control blocks irregular data. Tier 2, routing sends logic to reasoning models and math to execution models. Tier 3, output validation loops failed results backward with error tags until clean. Finally, state management tracks versions to prevent context drift. By explicitly tracking what the system has already accomplished, you ensure it will never ask the user the same question twice. The state is permanently recorded. These 4 tiers take an unreliable, single-pass AI response and transform it into a locked-in execution graph, driven entirely by strict standard operating procedures. Zooming out from the software architecture, building systems this way carries a massive implication for the industry at large. Once you lock all the safety, logic, and business value inside your orchestration layer, the underlying language model becomes a commodity. It is completely interchangeable. We have seen this exact cycle before. The specific database engine matters less than the object relational mapper used to interact with it. The physical CPU matters less than the operating system. Soon, the specific LLM will matter far less than the system governing it. True product moats, the competitive advantages that actually last, will be built on orchestration architecture, not on renting access to the smartest model. So where do you start? Directive 1. Identify your orchestration gap. Map your workflows to find exactly where human intervention is currently required to manually clean up an AI's output. Directive 2. Prioritize those fixes. Calculate the frequency of the error multiplied by the cost and solve those specific failures with structural validation rather than just writing a cleverer prompt. Directive 3. Acknowledge the risk. Launching any multi-step AI product without explicit state management is a ticking time bomb. Eventually, the tension will break it. The trajectory is clear. We are moving from prompting AI to orchestrating workflows to controlling autonomous systems. Let us know down in the comments where your orchestration gaps are right now and how you plan to close them.